Please write the title of 11.4 on your paper. Were you talking to me? What was your question?
It says that South has 6 hours on it.
We only have 6 hours. It's a 6-hour day.
After school, like they do it at, they have 6 hours and they do it after.
I don't know. Areas of regular polygons. After we're done, I'll look at it for you, okay? And composite figures. First of all, we need to review what a regular polygon is. Is a polygon with congruent sides and angles. How can we find the measure of the interior angles of a regular polygon? Does anyone remember how we do that? You guys remember something that had an n in it that we've done? It's n minus 2 times 180 divided by n, where n is equal to the number of sides. That will be the measure of each interior angle of a regular polygon every time. So if I had 5 sides, what do you put in for n? 5. Figure it out. That's what the measure of that angle is. Okay? So a pentagon, what would it have? It'd be what? 5 minus 2 times what? 180 divided by what? 3 times 180 divided by 5. What do you get here? Use your calculator, please. Huh? 3 times 180 divided by 5. 108. So right now, you know that each vertex angle of a pentagon, each interior angle, is 108 degrees every time with a regular pentagon. Only regular ones. But that's what we're going to be dealing with in this section. Okay? So, how about a regular hexagon? You'll deal with this one a lot. How would I find the measure of each interior angle for it? What would I do? Here, n was equal to what? 5, because it was a pentagon. What's n equal to here? In a hexagon? 6. So it would be 6 minus 2 times what? 180 divided by what? 6 minus 2 is what? So it's 4 times 180 divided by 6. What do you get as an answer? 120? See how you can, so that's each interior angle of a regular hexagon is 120 degrees. Now, I would like you to do your best to draw a nice big regular hexagon on your paper. As I am trying to do. Of course, this will not be perfect, but we're trying. I got pretty close right there. And then draw the center, a dot representing the center. Okay? What do we know all these angles are? Okay. All right, how do we find the area of a regular polygon? We have a simple formula, which is A is equal to 1/2 little a, big P. Say, what in the world does that mean? Well, A is called your apothem. Capital P is the perimeter. You guys know what perimeter is, don't you? It's the distance around. The new thing here is that thing called the apothem. Okay? Is the segment from the center perpendicular to a side. So it starts at the center and it's perpendicular to a side. Make sense? Another important thing to know about the apothem. Apothem always bisects the side it intersects. So the key word there is what? Can anybody tell me the key word there? Bisects. So what does that mean? It cuts this side in what? Equal halves. That always, always, always happens. What another thing that always happens is what kind of angle is always created here? A right angle. This is something you have to remember. The fact that they're perpendicular, you have to remember that because you can use it a lot. Because the other side I'm about to draw here is very important. This side right here, from the center to a vertex. You guys know what it's called? It's actually a word you've heard before. It's called the radius. If you had a circle that went around it, this is where the circle meets at the points. Radius. Segment from the center to a vertex. Center to vertex. That is what the radius is. There is also a very important fact that you need to know about a radius. The radius always, guess what next word's coming? Bisects the interior angle it intersects. So what does that mean? What does bisect mean? Anybody? Nobody knows what bisecting an angle means? Cuts it in what? Half. So this measure is congruent to that measure. Anything significant about that measure of that angle that's created with a hexagon? What is the measure of this angle then? The whole thing's what? So what's this one then? This one's 90, right? What's that one got to be? You guys were wondering why you did special right triangles last week while I was gone, didn't you? Guess why? Because anytime when you're finding the area of a regular hexagon, guess what they might try to do? Make you use what? Special right triangles to find this measure, or possibly find the measure of the apothem. Because to find the perimeter, aren't you going to need the measure of this side? Then multiply it by what? 6, if it's a hexagon. To find the apothem, they might give you, they might just give you the radius. They could, in this particular type of problem, they could just give you the radius. They could just give you the radius and you ought to be able to find the area of that regular hexagon. Because they gave you the hypotenuse, didn't they? So it's going to be, a couple of problems inside of the... Once you find the apothem and perimeter, how hard is that formula? Is it very hard? No, you put a number in there, you put a number in there, you multiply them and divide by 2, right? That's the easy part. It's finding the measure of the what? Apothem, and the measure of the what? Perimeter. That will be most of your work in these problems you're going to do today. Now, it doesn't have to be a 30, 60, 90. If it was a pentagon, when you drew the radius, it'd make a 54-degree angle, wouldn't it? but it would at least make a right triangle. Maybe you'd use Pythagorean's theorem to find one of them, right? The one thing that's going to get created here with the radius and the apothem is a right triangle is going to be created every time, is it not? Okay? This is your concept for today. I would definitely refer to these two facts down here. If you forget, first of all, you need to know what the radius and the apothem are, which one they are. Because I've seen people get confused. Which one was the apothem again? You know, because it is a new word. How many of you have ever heard of the word apothem before? Probably none of you. You know, the word apothem probably doesn't come along in too many teenage conversations. Agreed. It did all the time when I was in school, but you know. That was a joke, by the way. Anyhow, the point I'm making is you're going to need to review this little picture here, which one's the radius and which one's that. And remember that the apothem cuts that in half. Okay? So let's get out our little red books and let's do some simple problems, and then we'll venture on maybe into some more complicated problems. In these, they say find the area of each regular polygon. Okay. So in each case, you have a regular polygon, which is nice. So they're right in there. You know that your formula you're going to use is what? What did today teach you? The area of a regular polygon is what? 1/2 what? Anybody? A what? P. Right off the bat, they're making life really, really fun for you. Here with number 1. I have learned from my mistakes as a teacher. Before I did this section last year, we did not go over special right triangles again and trig functions. Should have, because, you know, you need to be reviewed of it. Get reviewed before you get into this, because you're going to use a lot. But in this section, basically you have two things you need. You need the apothem and you need the perimeter. Any one of these two do you know right now? Any one of them that you know information where you can find it just real easily right now? Can you find the perimeter real easily right now? We know this is a regular polygon. That's what they told us. So what does that mean? That means all these are congruent, right? So this is what? Can you tell me what the perimeter of this is? You may not, if you're not the best multiplication person in your head, you may have to use a calculator, but you have to multiply 3 times what? So what is that? 42. So we've got one of the two things we need for 1/2 AP. We've got the P. What is the other thing I need? I need the apothem. Let's call this X since it's our unknown here. What I would suggest is drawing yourself the triangle created by the radius and the apothem just a little bit bigger off here to the side. See how we did that? And let's examine the things we have. This is X, what we want to know, our apothem. Do we know what this side is? Well, if the whole thing's 14, what do I know that the apothem does each time? So I know this one is what? 7. Okay. But I don't know anything about the radius, do I? I better hope this is a special right triangle, or they haven't given me enough information, because I can't use Pythagorean's theorem because I don't have 2 of the 3, correct? Well, this is a triangle. What are the angles inside a regular triangle always going to be? If you can't remember that, put it into the formula, which was what? It's right. We'll get to it eventually. There. How many sides do we have here? So 3 minus 2 is what? So 1 times 180 divided by 3, which is 60. Would you agree? So I know that each one of these are 60 degrees. What does this do? It cuts it in half and makes this what? 30. If this is 30, this is 90, what's this? Do I have a special right triangle? How wonderful, I do. What are our rules about special right triangles? What do we always, always, always have to find first? S, the smaller leg. And you can find S two ways. Zoom out to review. Even though we went over it last week. This is S, this is L, and this is H for the hypotenuse. You always find S first, and S is either equal to, well, what's the hypotenuse equal to? And what's the longer leg equal to? Huh? Longer leg is S times the square root of 3. Everyone agree? Okay. What is the hypotenuse? 2 times what? S. Agreed? So the two ways to find S is you either take the hypotenuse and divide by 2, or you do what? You take the longer leg and divide by what? Square root of 3. Those are your two ways. In this particular problem, what has been given to me? Has the hypotenuse been given to me? This is L. S is what I want to find, and that's H. I don't need to worry about finding H, because I don't need it. I just need the apothem. But, now here's another nice thing. Round to the nearest tenth. So since they're going to have us round to the nearest tenth, there's no reason rationalizing the denominator once you, in other words, to find what S is going to be whatever L is, which is 7, divided by what? Square root of what? 3. When it's all said and done, that's your apothem, isn't it? Does everyone agree? You don't need to rationalize the denominator and worry about that, because you're just going to plug it into a formula and then get a decimal, aren't you? Does everybody agree? So I would just put it in your formula, 7 over square root of 3. Now, think of this as multiplying 3 fractions. You know, for those of you that have the calculators that can do this, it's great. Which you should have one, all of you should have one that can do it. But you need to be careful too. Make sure you don't make a mistake because you put it into the calculator wrong. What's on top here? What are we multiplying? On top, I'm going to put in parentheses, we've got 1 times what? 7 times what? 42? Does everyone agree that that's what's on top of those 3 fractions we're multiplying together there? Does everybody agree? Does everybody understand my logic there? So we're going to divide that by, now I'm going to use parentheses again, 2 times, square root of 3. I'll press over there to make sure it's on the outside, times 1. Now I'm going to close my parentheses. Everybody see what I got there? That's the weirdest answer I've ever seen in my life. How about we do it this way? You can also do it this way. 7 times 42 equals 294. Divide that by 2. Okay, now I've divided by 2, right? Now I need to divide by what? Square root of 3. Divide by 2. 294 divided by 2 divided by square root of 3. Decimal. You guys got this? 84.9 it would be, wouldn't it? meters squared. So we got the right answer both ways. So you see how using special right triangles can be interesting sometimes. Now, they may not always have you use special right triangles. Let's look at number 2. You may have to use trig functions. How wonderful. Let's look at this problem. For this problem, I need the apothem, and I need the what? Perimeter. Do I have the perimeter? Huh? I don't have it directly given to me, but can I find it easily? 10, 10. Aren't each of these 10? So what's the perimeter? 50 inches. But I have to find the apothem. To do that, we're going to deal with this triangle right here. What is the length of this side? Okay. Something I can help you guys with? What is this angle going to be? How many sides does it have? When we put that into our formula, what did we get when we did it last time? We did 5 minus 2. We got each vertex angle to be what? 108. So we know each vertex angle is 108. So what's half of the 108? 54. This is x. Does this look a little bit like the problems you did on the third set of worksheets I gave you last week? You have an unknown, you have a measure of an angle, and you have a measure of a side. The problem itself tells you how to do what trig function to use. With respect to the angle given to us, pay attention please. I'm not going to play games while I'm trying to teach something hard like this, or anything. Now, gave us a measure of an angle. With respect to this angle, what have they given us? This is the what? Opposite, and this is the what? Adjacent. SOHCAHTOA. Which one is opposite and adjacent? Tangent. So the tangent of 54 degrees is equal to the opposite, which is what? X over the adjacent, which is? To find x, all we have to do is what? Cross multiply and solve. So x is going to equal whatever the tangent of 54 is times what? 5. Let's put that in our calculator. Tangent of 54 times 5. I'd probably put that in as 3.369. That way you don't mess up. Always use more than, until you get to your final answer, always use more decimal places than what they want you to round it to. You know, 2 or 3 more. Okay, so let's put that in. So our apothem is 3.369. So now using, we'll ignore this one, now using this, 1/2, the area would be 1/2 the apothem, which is 3.369, times the perimeter, which is what? 50. What would our area be? Divided by 2. You guys get 84.2. And it looks like it was inches squared. Once again, finding the actual area is pretty easy, isn't it? It's finding the numbers you need for the area that can be difficult. But isn't it just a review of the things we did last week? What you should be getting better at, since it's the third time you would have done it now. What you have to figure out is whether you're going to use special right triangles, trig functions, or maybe Pythagorean theorem. Maybe they'll just give you the things you need. I know I scribbled out number 3 here, but if you look at this, in a regular quadrilateral, come in. What do we know the angles here are?
I need you to sound that, please.
Right now, give me a second.
Okay.
Give me about 15, or you can leave it here. Come back, pick it up.
Oh, I gotta turn it today.
Well, I mean, you come back, pick it up in 10 minutes.
In 10 minutes?
Yes, in the middle of a lecture.
All right.
Give me 10 minutes.
I'll just go get the other signature.
Okay. Now, if you look, what are all these in a square? Isn't a square a regular quadrilateral? These are 90, so what does that make this? So what you've got here is a 45, 45, what? 90 triangle. What is this side right here if the whole thing's 15? Can no one know 15 divided by 2? 7.5. Now here's the nice thing. What do we know about the legs in a 45-45 triangle? They are what? So what's the apothem? So you didn't have to do anything crazy there. You ought to like having those, right? So now I have everything I need. 1/2. Apothem is 7.5. The perimeter would be 15 times what? 15 times 4, which would give me 60. So that one was a little easier, wasn't it? Let's see, we have 7.5 times 60 equals 450, then divide that by 2. 225 square inches. We got a little bit of everything, don't we? So as long as they give you one of these 3 sides of the triangle created by the radius and the apothem, you've got a way to find it by using either what? Special right triangles, trig functions, or Pythagorean's theorem. The big thing here is, though, know which one you have. Know which situation. Like in the pentagon here. I knew that angle is 54. There is no 54, whatever that is. Well, let's see. Is 54, 40, or 36, 90 a special right triangle? No. So we had to use trig functions. However, we had a special right triangle here. It was a little easier. And we had a special right triangle what? On number 1. Okay? This is one of the harder sections. As a result, I may make this assignment worth 15 points and the others worth 10. Because this will take some time. And I may give you guys maybe next Tuesday to get it done. We'll see. Monday or Tuesday. But right now, for the rest of this hour, I want this worked on to try to reinforce what we've talked about. Okay? It's numbers 1 through 24. I know that took a while. Write problems, draw figures, show all steps in work. And I mean show all steps in work.